Here, let us do a sum over here in physics, right? A small pin fixed at a tabletop is viewed from above from a distance of 50 centimeter. What distance would the pin appear to be raised if it is viewed from the same point through a 15 centimeter thick glass slab held parallel to the table, mu g equal to 1.5? Right? So you have to first we have to chart it out where in which path the sum is being asked, right? I put up a diagram over here, right? And my solution part, right? One is a small pin fixed at a tabletop. Let us consider a table and a small pin is fixed at this top, right? And it's viewed from above from a distance of 50 centimeter. Let us assume this is my 50 centimeter distance and it is seen from this position. This pin is seen from this position. What distance would the pin appear to be raised? So we have to see what distance pin appear to be raised when if it is viewed from the same point through a 15 centimeter thick glass. So the distance here is same, but now it is viewed through a glass slab, which this glass slab is of about 15 centimeter. Alright. Now when you're seeing through this 15 centimeter, this seems like appear to be raised, right? And this glass slab, for your information, is held parallel to the table, and the refractive index mu g, it is given as 1.5, right? 15 centimeter, 50 centimeter, this is a pin. I have to determine how much height this pin have been raised, which means when I am seeing through the glass slab, this I have to find out my d is equal to how much. So what I am going to do for this, I am going to explain you with a simple concept, right? So let us see from this concept you will understand what I am trying to tell you. Let us say a beaker, right? This beaker is filled with water, right? This beaker is filled with water, and let us suppose an object is kept here. An object is kept here, right? If you want to view this object, how it looks like, right? This object, it looks like as it is. Let us say this object at this position. When you are viewing this object, because of the loss of refraction, it seems like this object is getting deviated, right? This is your angle of incidence on this surface, and because of this water medium, which is a denser medium, and this one you call it as air medium, this is a rarer medium, the angle of refraction which moves away from the normal, which means the object which is here, it appears to be at this position as your image location because of this loss of refraction. Let us say, right, according to your loss of refraction, mu is equal to your distance from the top to the bottom of the surface of this water, which is AO, which you call it as the original depth. You call it as original depth divided by, alright, this AI, which is your apparent depth. This is apparent depth. This gives your relation of refractive index when it is traveling from one medium to another medium. If I am taking the length of this medium as t, then my mu is equal to a naught, my a naught by ai. This is my original depth by apparent depth, right? This a naught is equal to the thickness of this particular medium, that is water which is contained here, t by ai, right? Ai, the distance from the top to the image where it is formed, right? Ai is equal to t by mu. I want to find out how much this object seems raised from this bottom position to this position. So that position, I can say IO is equal to my A naught, that is the original depth, and my apparent depth, that is AI, right? A naught is equal to my length, that is T, minus of this AI is equal to T minus mu, this I naught, right? From this relation you can try to make one assumption that I naught is the position that the object had been raised from the bottom level to this level. And just you recall over here, because of this medium, this needle appears to have raised. If I want to find out this raised distance, I have to make use of this formula, right? I naught, this is equal to T minus of T minus mu. So this I naught I can take it as D, which is equal to T into 1 minus 1 by mu, right? So this is my formula to find out the raised distance, right? So I can plug in the values which is that been given here. T is the thickness, which is of 15 centimeter. 1 minus of 1 by the refractive index of the glass is 1.5, right? And your mathematics 15, 1.5 minus 1 divided by 1.5. So this is equal to 15.5 divided by 1.5, right? 15.5 divided by 15, elementary mathematics, right? So 15 gets cancelled. This is equal to 5 centimeter. So the raised distance of this needle from the table because of the glass slab is 5 centimeter. So this is my answer, 5 centimeter. So D is equal to 5 centimeter. So this sometimes it I've been asked in many of the competitive examinations. The simple concept, this laws of refraction, as you should understand, when a ray travels from rarer medium to denser medium or from denser medium to rarer medium, how the ray gets refracted. And you should also know the relation of the refractive index between one medium to the another medium. So this is your original depth by apparent depth. You can calculate your apparent depth A equal to A naught by mu, and this is your apparent shift. This is your apparent shift which you are calculating in the sum. Alright, okay. So try to plug in the values and find out the answer whenever you come across sums like this, right? So you try to find out what is the question asked over here, what distance the pin appear to be raised, and you make use of this concept and find out the answer. All the best.